Hello everyone, it's September 8th. Alright, let's get to it. Spiral matrix. Two integers, m, n. So m by n, I also given head of a linked list of integers. Generate m by n matrix that contains the integers in the linked list presented in spiral order clockwise, starting from the top left corner and then go all the way in. Fill, if there are any remaining, fill it with -1. All right, straight enough. So we'll create it, and here we just go, and then we'll go down, and we'll go, and we will go up. Once we hit something that is not the -1, we just make a turn. And every time we hit, we just make a turn, and then we always turn right. Okay, I don't think this one is hard. So first things first, we need to say new int m by n, right? And then for int row of res, we're gonna say arrays.fill row with -1. Okay, and then list node head. And directions. All right, so we're gonna go right first, which is 0, 1, right? And then go down is 1, 0. Right, and then go left is going to be 0, -1, and go up -1, 0. Okay, and then we should say while node is not equal to null. Oh, we also need I0, J0. Right, so I, J both are 0, 0. Okay, so well, fill it first. We say res I j will equal to node.val. Okay, and then we move forward, right? No, we actually this. If res I j is equal to -1, then we put this in. Right? If it's -1, we assign a value, right? And then say node equal to node on next. And then we also int dir dir index. Okay, so I plus equal to dir's dir index, whatever this is, plus equal to dir index 0. And then j will be similar, will be 1. Right, so we go, move on, and then else. Right, else if we hit something that we have hit before, then we change direction. Right, we change, because we go here, right? We basically we go, we fill in, and then we move to the next one. And then if it's bad, then we need to reverse, then go to the next direction. So we first reverse it, right? We need first to reverse, right? And then +1, and we need to mod it. Mod 4, right? Then I plus equal to. Right, so we basically move to the next, and then we come back, then we check. And then we'll keep doing this until we're done. And then we return rest. Okay, let's give this a shot. That is interesting. Oh, it goes out. Okay. Yeah. Didn't consider that. All right. So if I is larger equal to 0, and I smaller than m, and j larger equal to 0, and j smaller than n, and they all good. We set it. Otherwise, we have to reverse. Okay. Yep. I think this is pretty much it. All right, we have 2326. Simulate the process. Initialize the result matrix with -1, then simulate the process. Each time we hit a cell that has been filled before, we do a clockwise turn. We keep filling until the entire matrix has been filled. No, until the entire linked list has been exhausted. Okay, there's one situation that I didn't know if it's gonna happen. Is m times n is always gonna be larger? Oh yeah. So that one will not happen. It will always work. Okay. All right. Let's see. Yep. It's pretty straightforward. Don't see any other. I don't know why it. Again, not the most. So OMN, right? Because we have to fit every single one. Unless you say there is a easier way to do this. I don't see. Simulation, OMN. Okay, so that's about it. All right, let's go back here. 136667. So we're gonna do 1367. All right, 1367. Yeah, I'm not sure if it's possible to finish the whole implementation today, but we do our best. All right, so we're gonna switch to Python. Ugh. Okay. Let's so this and okay. All right. Subpath. So basically, what we're gonna do is we'll try. In this solution, we will use an KMP substring matching algorithm to more quickly determine whether a path in the tree whether the linked list pattern is a sub-array, right, of any path in the tree. Okay, so we need KMP, right? Def KMP is sub path. So what do we need? We need a linked list, be a list of integer, and a path, gonna be a list of integer, and then we're gonna return a boolean value, right? And then we're gonna say this is going to be, this is the implementation of KMP with list instead of string. Okay, so def get LPS, I think. What we need is a list of so produce the longest prefix. Why is the longest prefix suffix, right? Longest proper prefix. Longest prefix suffix, yeah. Longest prefix suffix. Alright, for the given LPSI equal to the maximum length, right, of the prefix that matches the suffix ending at array I. Okay, so LPS will equal to 0, right, times the len array, and then for I in range 1 to len array. Alright, so we also need to know L, current length is 0. So this is current max length of matching prefix. Okay, so we say for I from 1 to the n, now we can check. So we say if array I is equal to LPS len, current length, right? If these two are the same, yeah, if they are the same, then we move forward, right? I plus equal I plus equal 1. Ooh, maybe I shouldn't do that. All right. I don't know. Alright. So we say I plus equal 1, current length plus equal 1. Right? We say if they're the same, then length plus equal 1. Yeah, because we match one more, and I plus equal 1. right? And then, ooh, I, what the hell is I? I is index on the array. Yeah, I is index on the array. And right, and then otherwise, if they're not the same, else if array I and then these two are not the same, then we need to readjust the length, right? Because they're not the same, then we need to know where array I need to compare to. We don't know where it needs to compare to, right? We don't know where it needs to compare to. So I need to check. I need to readjust the length. So the length will be current length minus 1, that position, right? That position is the end, which is just to the left of array I. So we need to know what is the maximum at that. So this shall equal to LPS current length minus 1, right? What if current length is equal to 0? Yeah, if current length is equal to 0, then it don't do anything. But if the current length is not equal to 0, maybe we should do an elif. Current length is larger than 0. Then you readjust current length, and then we'll try it again, and then at the end we'll return LPS. All right, I'm not 100% sure, but let's take a look KMP. Let's see if this one is correctly implemented. Oh, I think you forgot to assign. Yep, my bad. I think I need to assign. Yeah, I need to assign LPS I equal to current length. Okay, when I assign LPS I equal to current length. Otherwise, oh, we missed this situation. So basically, if the current length equal to 0, what do? Current length equal to 0, and they're not equal, then, oh, it's a forever loop. Okay. Else, so the current length is 0. Right, current length is 0. That means impossible to match anything. Then I just move I forward. Yeah, move I forward. And because I already set LPS to 0, so I don't have to change anything. Just move I forward. Okay, so that's LPS. Yeah, not the best. Right, not the best. So we now have KMP match. We have source. Okay, pattern. If length source is let's say m equal to source I like to do this way. So pattern is m. So if n is smaller than m, let's return false. Okay. Otherwise, then we need to do LPS equal to self dot get LPS pattern. Okay, so we have the LPS. Then we need to have ij equal to 0, I equal to j equal to 0, right? Okay, so I is on source, j is on pattern. Now we need to start comparing, right? Start comparing. We can say while n minus I is the remaining, if the remaining is larger or equal to n minus j. That is not true. Source is m. I'm gonna switch this. Source is m, this is n. So source is m, this is n. The condition is to check whether there is enough source to match pattern, right? And actually it's included, this one, right? This one's included, but I like to put the other one else. So once it's good, then we're gonna check, right? We need to check. So if source I equal to pattern j, right? If these two equal, then move forward, right? And then if j is equal to n, so we get to the, then we just return true. That's all we want. We just need to match. Then we have a match, right? So if j is not equal to n, then we need to check if they are not the same, right? We say if I and j are not the same, because if I and j is the same, then we should just move on, right? So we should say if source I not equal to pattern j, yeah, this one I think shouldn't be here. I would put it inside, right? And if they're equal, you do this, right? You move forward, and then here we probably can just do else. If they're equal, we move forward, we check if it's good. If it's not good, which means haven't finished, so just keep moving, move to the next one. If they're not equal, right? If they're not equal, then we need to find the new comparing. Yeah, what should we compare? So if they're not equal, so I and j is not equal, I need to find out, so j minus 1, so j minus 1, I minus 1, they're matching, right? So we need to find out j minus 1 on LPS. So I can say j, the next one to match shall equal to LPS j minus 1. So this is the next element in pattern to match source I. Right? And then we move on. And then if we go through the whole thing, nothing matching, then we return false. All right, so this is very important. Okay, this is oh shoot. Ah, I didn't realize this one in the wrong position. All right, I need to see if this implementation is correct. There's a pattern's M, so it's that's okay. That's not too big a deal. And if equal, if this. Oh yeah. This has to do this one as well, right? This has to do this as well. And but for us, we just exit. And for them, I check for this and oh shoot. Yes, j has to be larger than 0. It is. If j is equal to 0, then we just move I forward. Yep, if j is equal to 0, we move I forward. Yep. Okay, so we say elif j is larger equal to 0, else I plus equal to 1, right? J is 0 and there is no match. Just move I forward. Okay, so that's that. All right, and then we only return true or false. So there's one more check. I mean, if m minus I, so I definitely. Oh, I plus equal to 1. Huh. I plus equal to 1. But it's fine, right? If I gets out, hold on, it's different because here we do this one first and I move I forward already. Right? I move I forward and move j forward. Both I move forward. We're considering the next one already. And I don't understand. Here is different. Here I say I move I forward and move j forward, right? And then I just go on for the next round. And then if they're not the same, and then I check for j, and now I reset the j's position, right? And otherwise I fall forward, and then we go up. I don't see an issue with this one. I don't see an issue with this implementation. I can even record it. It's, you know, it's fine. No, we know I move on to the next position. It's okay. And if they're not the same, we reset to the j's position, and then, yeah, I don't understand. All right. Anyway, so if is subpath, I need get LPS match and def DFS. Right. DFS, I need the node, which is optional, not list node, tree node, right? And then path is a list of int, and it's also return boolean value. If node, if not node, right? Then return self.kmp math, path and linked list. Okay, so self.kmp match path and linked list. Okay. Otherwise we say if self.dfs node.left. Oh, path.add node.bow, and then node.left path linked list, or self.dfs node.right path linked list, turn true, right? Oh, it's not add. Otherwise, we'll have to say path.pop and return false, right? A semicolon. Alright, so now this one we can just say return DFS. I need a thing. Linked list node equal to list node. We'll call it list node head while list node linked list add append list node dot val and list node dot next. Okay, and then we'll do head path and linked list. Okay, DFS is now defined. Self.dfs. Incompatible between argument 1 head. Oh, wow, that's good. Yeah, it was good. Saved my behind. Now, that's the thing. Like, right now, I don't... If it fails, right? If it fails, I don't know if it's because... if it's because the KMP is wrong or because... Oh! Huh? Wait, what? Oh, I didn't copy the whole thing. That's funny. I didn't copy the whole thing. That's not right. Okay, so DFS. Well, we can do this. We can print. Just check. Actually, we should just focus on here. Print source and path, just to see. Source is 1 4. Huh? How is the source 1 4? And source is 1 4 because I go here and then I go this. That kind of counts, right? And then so but that's 1 4 2 1 is the first. But why 1 4 2 1 happened twice? Okay, what is a path? Downward path. Okay, so I need to change. If not, no. So we do this, and then we should say if left and right both are none, then we check. Okay, so basically we say if not node.left and not node.right. Always add the path first, and then we say if that is the last one, we run this check, right? Otherwise, we say if if this, if node.left and this return true, right? And then if node.right and this return true, and now return false. This shall restrict to 1421, 1426, 1426. Yes, okay. So now the problem is because 428, 414, 144. Huh. That is problem. Okay, maybe we should say a verdict is false. Res is false. Res equal to aleph I have a left, res all equal to this. Nope. If res all equal to this. Okay, and then we pop it, and now I'll return res. Okay, so now the issue is different. The issue is just KMP matching. God Lord. Why would it not be? So n is pattern, so pattern will be 3, right? 3 smaller, that's no, because m is bigger. And LPS. Okay, let's this LPS will, it should be just 0, 0, 0, right? This LPS is 0, 0, 0. Huh. Oh. That was the issue. I changed what M and N stands for. LPS hasn't even been mentioned. Oh, shoot. LPS hasn't been mentioned. I deleted the wrong thing. Yep. And try the others. Yep. Ugh. Oh, that hurts. 2 to 1. What's the tree? 2. Oh. 2. No. 2, no 2, no 1. That is funny. Okay, 2, 2, 1. Let's say print source pattern and LPS. Source pattern LPS. That is wrong. The LPS is wrong. Okay, we have issue with LPS. LPS is 0, 0, 0. Should be 0, 1, 0. Okay, I is 1, so array I is equal to LPS current. LPS current. No, it should be array. It should be array current length, right? Yeah, it should be array current length. Yes, array current length. That's the error. It should be array current length. 0, 0, 1. Oh my goodness. Oh shoot. Yeah. Blah blah blah. Order matters. Okay, so let's remove this one again. Run the previous test case again. Okay, that's good. It works. It works, but this is not what we want. So there's one more solution to go for this one. Yeah, but I am happy that oh shoot. Oh hell. I have to redo the whole thing. Okay. Alright, I have none of path.node. Yeah. Node is not going to be optional. DFS, because the tree is always, yep, so this is, oh shoot, this is always gonna be available. We probably will have another error here. Yeah, tree root. Let's say if not head, if not root, return false. Right? Yeah, that's good. This is not. This is most likely not the final version of KMP, but it is an easier way of matching. Not easier way, it's a faster way. It's a faster way of matching subarray. Okay, so that's that. We'll have to work on this again tomorrow, which is good. That's all right. It's good to write KMP again and again and again. All right, I'll see you guys tomorrow. Adios.